The alert came in with a familiar pattern: high latency on API endpoints, then another. Error rate above 20%. Slack started moving quickly. Scaling is not helping. Pods are increasing, but response times are worse. Why is CPU low but latency high? I opened Grafana. Request rate was climbing. Nothing unusual. We had seen higher. Then I looked at pod count. It had doubled, then tripled. Autoscaling was doing its job, but latency kept rising, and error rates followed. That's when I realized we were scaling, but nothing was getting better. We were running on AWS EKS cluster in US East 1, about 80 microservices. Traffic averaged around 3K requests per second. During peak, it could go up to 8K. Horizontal pod autoscaler was configured based on CPU and request rate. Cluster autoscaler handled node scaling. Front-end traffic came through CloudFront, then an application load balancer into the cluster. Back-end services connected to RDS, PostgreSQL, and Redis. We also had a shared external service, a recommendation engine hosted separately. CI/CD was GitHub Actions and Argo CD. Monitoring stack included Prometheus, Grafana, and tracing. The system was designed to scale horizontally, add more pods, handle more traffic, at least in theory. Users reported slow responses, then intermittent failures. Some requests completed, many timed out. From the system perspective, things looked healthy. Pods were running. CPU usage was low. Memory usage was stable. No crashes. But latency was high, which meant something else was the bottleneck. We checked database, moderate load, not saturated. Redis was fine. Cache hit rate was normal. That was confusing. Everything looked under control, but the system was slow. First thought was network issue. Maybe latency between services. We checked service mesh metrics. No anomalies. Next thought was database contention. But queries were not slow. Connection counts were stable. Then we looked at request traces. That's where things changed. Each request spent most of its time waiting, not computing. Waiting on an external call, the recommendation service. Every request hit it, synchronously, and its latency was high, around 700 milliseconds. Now we checked its metrics. It was overloaded, request rate had increased, but it was not scaling. It was a fixed cluster. Now we had a clue. Our system scaled, but it depended on something that did not. As traffic increased, requests to the recommendation service increased. Its response time slowed. Our requests waited longer, which increased overall latency, which increased the number of concurrent requests, which triggered more scaling, which generated more load. A loop. Now Slack was escalating. Should we disable recommendations? Can we bypass that service? Users are timing out. We had to act. The root issue was a hidden bottleneck, a synchronous dependency on a non-scalable service. Our architecture assumed that all components could scale horizontally, but the recommendation service was not part of that system. It had a fixed capacity, and every request depended on it. As traffic increased, it became the limiting factor. Adding more pods only increased the number of requests sent to it, which made it slower, which made our system slower. Horizontal scaling amplified the problem instead of solving it. First step was to reduce dependency. We introduced a fallback. If the recommendation service did not respond within a threshold, we skipped it. Returned a default response. That immediately reduced latency. Then we added caching. Stored recommendation results for short durations, reduced the number of calls. Next, we rate limited requests to the recommendation service, prevented overload. We also coordinated with the team managing it. They scaled their infrastructure, but that took time. Our fixes gave immediate relief. Latency dropped, error rates decreased. Users saw faster responses. Full recovery took about 35 minutes. Most of that was deploying and validating fallback behavior. What failed was not scaling, it was assumption. We assumed all parts of the system could scale equally. We did not account for external dependencies. Detection was also delayed. We saw high latency, but did not immediately identify where time was spent. Tracing helped, but we were not actively monitoring dependency latency. There was also an architectural gap. Critical path depended on a single external service, without fallback. Horizontal scaling only works when all components can scale. Dependencies must be evaluated for scalability. Synchronous calls in critical paths increase risk. Fallback mechanisms are essential. Tracing should be used to understand where time is spent, not just how much. And finally, adding more resources does not always solve the problem. Sometimes it makes it worse. In the end, we scaled everything, except the one thing that mattered: